Hello, welcome to Special Maths Academy. In this video, we'll be looking at solution to the just concluded Special Maths contest. Okay, for this problem, it's a probability. So first of all, we just analyze what it takes for a 3-digit number to be divisible by 11. So let's say the 3-digit number is A, B, C as the digits. So decimal expansion will be 100A plus 10B plus the units C. So this is divisible by 11 if this is congruent to 0 mod 11. Now 100 is congruent to 1 mod 11 because 99 is a multiple of 100. So here we can actually simplify this as A minus B plus C congruent to 0 mod 11. So that is A plus C is congruent to B mod 11. What this means is that either, since you are dealing with numbers from 1 to 6, as we're making use of standard dice, the highest this can get will be 12. So it's possible that this number is already bigger than 11. So this means that we have two options: either A plus B is exactly A plus C is exactly B, or A plus C is B plus 11. Any more than that will be out of our range. Okay, so these are the two categories we'll be considering. For the second one, there are fewer options because we know this is less than or equal to 12, so B can only be equal to 1. Since we cannot have B is 0, and if B is 1, we must have A plus C is 12. And since we are dealing with numbers from 1 to 6, the only way this is possible is if A and C are both equal to 6. If any is less, then the other will have to be higher. So either we have this, or we just have A plus C is equal to B. So I'm going to just write out the triple of A, B, C we could have. So if we want to get somewhere B here in this first category, we cannot have B equal to 1. The least we can have is 1 plus 1, so which is 2. So we can have B is 2, and A and C will both be 1. Or we could have B is 3, where A is 1, C is 2, or A is 2, C is 1. I'm not going to write that one because I'm going to explain a bit. So let's write the others. So here we see that we can permutate A and C and nothing really changes. So I'm just going to consider other scenarios. For 4, we have 1 and 3, or 2 and 2. For 5, we have 1 and 4, or 2 and 3. Others will just be permutations. And then 6, now we have 1, 5, we have 2, 4, and then we have 3, 3. And finally, for the other category here, this is specifically going to be 6, 1, 6. Okay, so these all have different composition. Now for the problem, we are given 3 standard dice, right? So once we label the dice 1, die 1, die 2, die 3, then we see that the sample space is going to have a total of 6 raised to the power 3 possibilities. That's 6 for the first one, 6 for the second one, and 6 for the next one. And now if we had, for example, 1, 4, 3 as the outcome in the 3 different dice, then we see that even if we had something like 3, 1, 4, this will still be a valid outcome, desirable outcome, because we can reorder this to form the number 1, 4, 3, which is a multiple of 11. So once we can do that, then John wins. So that will be counted on the side of John. So this means that we just need to figure out the composition, then look at all the possible permutations that could have occurred. Okay, so we just count all these with their permutations. For 1 2 1 2 1, we have some repetition, so there are only 3 possibilities, which is determined by where 2 appears, whether in the first die, the second one, or the third. So here we have 3. Where there's no repetition, this will just be 3 factorial, which is 6. So most of this will be 6, and then when there's repetition, it will just be 3. So that's what we have. 3 3. So we can just calculate this. So we have 3 times 4 plus 6 times 6, which is equal to 12 plus 36, so that's 48. So we have a total of 48 that satisfies what we need out of 6 raised to the power 6. So the probability here is 48 over 216. So we can cancel out 6 here to give 36. 6 here will give 8. Then 4 here is 2. 4 here is 9. So this, in the most basic form, is 2 over 9. And so when we add 2 and 9 together, we get option A, which is 11. Alright, I hope you enjoyed this. So I'll see you in the next one.